Hello everyone. Am I audible? Okay, so is my voice clear? Is there any background noise? Okay, that's good. Okay, and so shall we start? I did start the YouTube stream. It takes a little bit to update, and I have started the YouTube stream. Let me check. Okay, it started. Okay, so yesterday we were talking about binary search and linear search and searching algorithms and how sorting can be used to solve a problem. And today we are going to be solving the problems. So we are going to be solving the problem set problems from day before yesterday during 11th. If you didn't see that in problem set, you should definitely go check out Discord, and we are going to be checking those problems. So today we are going to be covering the problems, and we are also going to be covering sliding window and prefix sums if we get time. So we are first going to be talking about sliding window. We are going to be starting with the problem. So first a recap, we talked about linear search and binary search, and today we are going to be requiring arrays again a lot. So you should definitely know arrays and do check out arrays if you don't know them already. And also again we are going to be using zero-based indexing just so that people don't get confused. Okay, so now problem statement. Print out the sum of every k consecutive elements of an array. So for example, if k array equal to 1, 2, 3, 4, 5 and k equal to 3, then you print the sum of these 3 and the sum of these 3 and then the sum of these 3. So this is what the problem statement asks. So you need to print out 6, 9 and 12. So can you guys think of any way you would do this? How would you do this normally if you were, required to solve this problem? How will you solve the problem? So you guys can go ahead and give your solutions in the comments. Yeah, we will look through that. And so there are two ways you can solve this. The first way is the brute force way. The brute force way is just adding these three, and adding these three. So count the number of times this runs. This runs for 9 times. So this takes 9 iterations, which is 5 minus, so we have three windows or three consecutive elements, 3k consecutive elements. So this is 3 times 3, because 3 is the size of the array. So if say there was also another element 6, then there would be 4 windows or 4 consecutive elements subarrays. So this would be 4 times 3. So the number of times this loops through, if we count it with a brute force manner, the number of times it iterates through this array is equal to, yeah, you can also use ransom query. Ronak said you can use ransom query, which is right. So this is uh, 12. So if we assume there's a 6 here, then there should be 4 windows, which is equal to the number of elements. The number of elements is 6. 6 minus k. K is equal to 3 plus 1 times k. So this is the total time taken if you use the brute force method. You would also add 4 plus 5 plus 6 equals 15. So this would also be there. So this would be 12 times. So now we are going to be talking about how brute force solution works. So brute force implementation. For I equal to k minus 1 to n minus 1. So if we have 1, 2, 3, 4 and 5 and k is equal to 3, we are going to start at index k minus 1. Notice that this is this is one zero based indexing, so we are going to be starting with k minus 1 to convert it into one zero based indexing from one based indexing. Now k minus 1 to n minus 1, we are going to be iterating through. K minus 1 is 2, this is index 0, index 1. Please remember that this is the index. So 2, 3 and 4. So now let's start from index 2. So we are going to be starting at index 2. and we are going to initialize sum as 0. So the sum is equal to 0 initially, and then for j equal to I minus k to I, so I is equal to this index. Please remember that I is equal to this index right now because it starts at k minus 1 and ends at n minus 1. So we are going to be initializing j as this index. So j is equal to the index 0. So I minus k is actually I minus k plus 1. I'm really sorry about that. It's I minus k plus 1. So we are going to be starting at index 0, and then we are going to be going to index 1, and then going to index 3. I mean index 2. And we are going to be adding all three of these. So now it will be going to index 0, and then it will move on to index 1 and add it to sum, and move on to index 2 and add it to sum. So this is what this program does. Did everyone get it? How the brute force implementation works? Oh, okay. So if you didn't get it, react with the confused emoji. Okay, so one person didn't get it. So basically, we are going to be starting at index 2. So 1, 2, 3, 4, and 5. And we are going to be starting at index 2, which is this index. And then we are going to be iterating through I minus k plus 1. I minus k plus 1 because we want to be at index 0. So you are at index 0 now, j is equal to 0, and j is going to be from 0 to 3. So it's going to be at index 0, index 1, and index 2. So this will take the sum of all of these three indices. So it will take 1 plus 2 plus 3. Okay, so you guys, I guess everyone got it. So if you didn't get it, please react with the confused emoji. And okay, I'm going to move on to the next slide. So sliding window. Sliding window is an optimization for this problem or similar problems. Sliding window is an optimization that can convert some nested loops into a single loop. So nested loop is called, nested loop is defined as a loop inside a loop. So this is I equal to k minus 1 to n minus 1, and inside the loop there's another loop. So the total complexity of this brute force algorithm will be n minus k times, so n minus k because we are iterating n minus k times in the first, this will iterate for n minus k times, and I minus k to I, so this is equal to k. So n minus k times k. So this is basically equal to nk minus k square, right? So did you all get how this complexity works? So basically now we can remove the k square because we know k is less than n. So if k is, yeah, that's Diwali crackers. I'm really sorry, Suil. Okay, so k is first of all the size of the window. So now we know that the size of the window has to be less than the total size of the array. So if the size of the window is greater, then that means we won't have any other, any way to add anything. So k is less than or equal to n. So we definitely know this. So now we know that n times k will be greater than k times k because k is less than n, less than or equal to n. So n times k has to be greater than or equal to k square. So we only keep the highest order terms in time complexity. So we are just going to keep O of nk. So O of nk is basically a lot of time. So this takes too much time. For example, say k n equal to 100 and k equal to 10. So this will be 1000 times. This will iterate through the array 1000 times. So you can see how it might grow in the future. So if it's 100, then it will be into 100. So this will be even more. So we are not going to be using this brute force algorithms when we need to, when we actually need to use it. So we are going to be using a more advanced algorithm, a more, faster algorithm designed for this type of problems, which is called the sliding window. So you can imagine the brute force algorithm as a window. So there's an array, and the brute force algorithm takes a window. So window is equal to the k elements. The window is equal to k consecutive elements. And now each time we are removing this window and inserting it again. So this is a waste of time. So instead of removing the window, sliding window just removes first part of the window and adds in at the last part of the window. So it moves the window a little by little. So instead of moving it entirely and removing it and inserting it entirely, it just consecutively moves the window instead of moving the window, removing the window and inserting it again. So yeah, it is called sliding window. Now, sliding window is an optimization that converts nested loops into a single loop, converting O of nk to O of n, where k is equal to the size of the window. So you can use this for the sum of every k consecutive elements or the max of every k consecutive elements or something like that. You can also use it for XOR of every k consecutive elements. So now we are going to be moving on to sliding window sum. So there's a window of k minus 1 element, k elements, and then this consists of k elements, and the next window will contain of k minus 1 similar elements. So it will consist of these values. Only this and this are changed. So the last value and the last value of the current window and the first value of the previous window are changed, right? So does everyone get this? If anyone doesn't get it, please react with the confused emoji. Okay, I guess everyone got it. So we will be moving on. So for example, if k equal to 3, a window could be ai plus 1 and a of I plus 2. So the next window from this window would be a of I plus 1 and a of I plus 2 and a of I plus 3. We are just going to be adding one window to each of this, one value. Okay, so this is the first window and this is the second window. Now notice that AI is not in this array, this window, and AI plus 3 is not in this window. But these two are already on the same windows. Okay, so we are just going to be moving this, removing this AI and adding this AI plus 3. So this would be just two more iterations. So this is just two more iterations. So we are going to be using that. So we are using the above observation to find this formula. So this formula is the sum of window 2. So we don't know the sum of window 2, but we'll know this formula of sum of window 1. So window 1 is equal to ai plus 1 comma ai plus 2. Let me erase all this. Okay. So ai and ai plus 1 and ai plus 2 is equal to the first window. And the first window minus the first window, the zeroth element of the first window, which is equal to ai. So we are going to be taking this total sum and then removing ai from it, and then we are going to be adding the last element of window 2. The last element of window 2 is ai plus 3. So we are going to be adding ai plus 3. So now notice that this formula gave us the exact same result as the sum of the window 2. So did everyone get it? I guess everyone got it, hopefully. Yeah, so this is what sliding window means. So basically imagine it as a window and imagine that you are moving the window. You wouldn't remove the window and put it back again. So that would be a waste of time. So instead we are just going to be moving the window. We are going to be sliding the window through the with the pane or anything like that. In this case the array. So with this will convert O of nk to O of n. How? So we just have to compute the first window. The first window is A0 plus A1 plus A2 and so on to AK. So we are going to be taking this and we are going to be turning it. So we are going to be to get the next window. This is the first window. This is the first window. And the second window will be equal to the first window. This is actually a k plus k minus 1 because we are using zero based indexing. So ak minus 1. So this is the total sum of this. Let's denote this by S. So let's denote this by S. So the next value will be equal to S minus A0. So S minus A0 will remove this value and we are going to be adding AK. So adding AK gives you A0 plus A1 plus dot 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 to AK. And we are just going to be removing this value. So now you can imagine how this would work for the next the next window. So the next window we are going to be removing A1 and we are going to be adding AK plus 1. So this will give you A2 to AK plus 1. So notice how we are getting the sum of each window, right? So everyone got it hopefully. If you didn't, please tell me so. So this is how sliding window works. Sliding window is a really good optimization. So it's very important and using it will really help you. So now I'm going to be asking a problem. Hopefully you guys will use sliding window to solve the problem. So the problem is actually you can solve it with brute force by using a calculator or something like that. But I recommend you guys to use sliding window. So this is the implementation. First of all, this is the implementation, how we would implement it. So first of all, take the first window and print the sum. So print the first window, and for each other window from k to n minus 1. Notice that we are not taking k minus 1 because we already have the first window here. So we are going to be ignoring the first window and we are going to be moving from k to n minus 1. And we are going to be adding ai to k, I mean ai to the sum. So this will, for example, if this is 0, this will add ak to this value, and we are going to be removing a of I minus k. So k minus k is equal to 0, we'll be removing this value. So a0 is going to be removed from the total window. And then for the next window, that will be a k plus 1, and we'd be removing a k plus 1 minus k, which is equal to a1. So a1 to a k plus 1 will be removed. So this will become a1. So did you guys get it? And then we'll print the sum. So we definitely have to print the sum. And everyone got it, I guess. Oh, someone didn't get it. Um, so didn't you get the implementation or didn't you get the whole thing? If you could tell me in the comments, that would be really helpful. So, okay, the implementation. Okay, let me explain again. So basically, you're taking the first window. This is the first window, and the first window is taken, and then we are going to be printing the first window, and then for the next windows we are going to be removing ai minus k. So a of I minus k is the first value, so this is a0 and this is a k minus 1. Okay, so this is a of k minus 1, and we are going to be removing a of I minus k, and k is I is equal to currently, so okay, k is equal to currently, I mean I is equal to currently k. Sorry, I was busy reading the chat. Now we are going to be removing the last value. The last value is a0. So we are going to be removing this because we want the next window. So the next window is the last window's first value is equal to I minus k. So I hope you got that. So the last window's first value is I minus k, and we are going to be removing that. And the current window's last value is equal to a of I. So we are going to be adding a of I. So a of I is equal to a of k, and both of them are the same thing for the second window. So this is how we got the total sum. Okay, so now moving on. So you guys please try and use sliding window for this problem. So I'll create a poll. I'll give you a bit of time because this needs some time. So So most of you have got it right. I think one person messed up. Most of you have got it right. Okay, I think everyone got it. So the answer, okay, almost everyone got it. So the answer is actually 6 because this is 4 minus 4 plus 6 minus 4. This is the second window. This will be the maximum sum. You can actually, let's discuss the solution. So this is, wait, okay, so first of all, we are going to be taking the sum of the first window. This is equal to 5. And then from 5, we are going to be removing 3. So this is the total sum, and we will be removing 3 and adding 4. So this is 5 minus 3 plus 4, which is equal to minus 3 plus 1 is equal to 1. So minus 3 plus 4 is equal to 1. So 5 plus 1 equal to 6. So the sum of the second window is equal to 6. Then we'll remove the minus 4. So 6 minus 4. And then we are going to be adding negative 15. So we are going to be adding negative 15, which is equal to 6 minus 4 is 6 plus 4, which is 10. 10 minus 15 is equal to minus 5. So from minus 5, we are then going to be removing, let me share the leaderboard. Yeah, Nishay got it in 3.1 seconds. That's really impressive. Congrats, Nishay. So then negative 5, and then we are going to be removing, this was the current window, and then we are going to be removing 6. So minus 5 minus 6, and we are going to be adding 12. So plus 12. So this is equal to 1, and then we are going to remove 4, which is equal to 1 minus 4, and then we are going to be adding 6. So 1 minus 4 plus 6, which is equal to 3. So this is the final answer. So the last window has a value of 3, and the window before that has some other value, and so on. So now the total maximum value is 6. So this was the answer, and yeah, it was easy because it was designed to be easy. Yeah. And then, so we are going to be discussing the first problem of the problem set, which was conducted on day 11, date 11, just before the previous session. So we held a quiz, and if you didn't participate in the quiz, do take a look because we are going to be discussing those problems right now. So sliding window, searching, sorting and sliding window problem set 1. There are 8 candies with sweetness levels 7, 15, 40, 12, 8, 19, 4 and 7 respectively. And there are 8 children in a queue. The first child in the queue can take as many candies as they want, and they can take candies from any position. So for example, in the list of candies, you can take any candy from any position. You can take this candy, or you can take this candy, or any other candy. So it's just your choice. As long as each of the candies have a sweetness level, for example, here it's 70, 7, 15, 40, and so on. And each of the candies have a sweetness level. and eating a candy will add that sweetness level to the total sweetness level. So the total sweetness level the child ate cannot exceed 28. For example, the first child can't eat 15, 7, 8 and 4 because the total will be greater than 28. So 4 plus 8 is 12, 12 plus 12 plus 15 is 27, 27 plus 7 is equal to 34. So this 34 is greater than 28. So we are not going to be here. He can't eat these candies in this order at least. So now you want to know, and after the first child eats, the second child comes and takes in the rest of the candies. So he also can repeat the same thing, but with the rest of the candies. He doesn't have access to the previous candies that the previous child ate. So now the process keeps repeating, and the children want to eat as many candies as they want without exceeding 28. So they don't care about the sweetness level. So they don't care if they eat 7 or whether they eat 15 or whether they eat 12. They just want to eat as many candies as they could. So they'll pick the candies to maximize the number of candies that they eat. How many children will get at least one candy? So now after the first child takes the candies, the second child can take some more candies, third child can take candies and so on. And when does a child not be able to take any candy? So for example, if everything is exhausted, then that means that you can't take any other candy. And Simon says has the right answer. Sort and take as much as you can. That's exactly the answer. So this is actually called a greedy approach. So greedy approach means that you take what's best for you in the current moment, and I believe you'll talk more about it in the future videos, future sessions. So for now we are going to be ignoring that, and we are going to be talking about how sorting helps. So notice that the children must take the least sweetness, the candies with the least sweetness, if they want to eat as much candies as they could. So otherwise, if they take the candies with the most sweetness, then they won't be able to eat as much candies. So the first child will sort the array and take as many candies, the smallest candies. So the smallest candies are 4, 7, 7 and 8. So after if he eats 4, 7, 7 and 8, the total is equal to 14 plus 8, 22, 22 plus 4 is 26. So after he can take 26 and 26 is less than 28. So this is a valid arrangement. So he can take these 4 candies and the first child has his share done. So notice that if it takes 12, it will go to 38, which is greater than 28. So if he eats 12, then it won't be possible. So therefore he stops at 26. So now that's one child done. And the second child these are all done by the first child. So the second child can take only these candies. So the second child takes 12 and then he also takes 15. So 12 plus 15 is equal to 27, which is also less than 28. So this is a valid arrangement we can take. And notice that he can take 19, or he couldn't take, instead of 15, he couldn't take 19 because it will exceed the total. So now the second child has taken as many candies as he could. So now these two are gone and he has 27 less than 20, which is less than 28. And now 19. So 19 is the only value which the third child can take. As if he takes 40, it will go to 59, which is way greater than 28. So third child takes 19, which is also less than 28. Now notice that the fourth child can't take anything, because if the fourth child takes 40, then it will instantly exceed. So in this case, the fourth child can't take anything and everything is exhausted. So only 3 children get at least one candy. Okay, and now I'll address that later. Pranav, I'll address that later. The other children cannot take any other candies since the candies left with the least sweetness is 40, which is higher than the limit. Therefore, the answer is 3. So if anyone didn't get this question, please react with the confused emoji. Okay, I guess everyone got it. So I'm going to move on to the next problem. Also, if you didn't get any of these, no, if you have any technical issues, I mean, if I have any technical issues, please let me know. If I'm not audible or anything like that, please just tell me, and I'll fix that immediately. Okay, so the next problem. So first of all, let's take a look at the implementation before we go to the next problem. So the implementation is very simple. Sort the candies by their sweetness, and then count equal to 0. Count is the total final answer. So count is the final answer, and while there are candies left or the sweetness of the smallest candy is less than or equal to k, while the total is equal to total is the current sum of the current child. So if the current child has taken 4, then his total will be 4, and if he has taken 7, then his total will be 11, and so on. So now, while the total is less than or equal to k, after the candy has with the least sweetness taken. So this is done to make sure that we, 4 plus 4 plus 4 plus 7 plus 7 plus 8, and in case we don't declare this after, we should have added 12 to the total. So if we took before, then it will be wrong. So we are going to be taking it after the candy with the least weight is taken. Then remove the total smallest candy, and of course add total I mean add the current sweetness to the total. Total equal to total plus sweetness. So now the final answer is the value of count. So each time it iterates through, one child takes at least one candy. So this is the only answer. I hope everyone got that. Did everyone get the implementation? React with a thumbs up if you did, and if not, please react with a confused emoji. Okay, I guess everyone got it. And then let's move on to the next problem. So there are 13 sticks side by side with sunlight detectors on the tip of each stick. The heights of the sticks are this values. I don't want to read them out because it will take a bit too much time. So these are the heights of the sticks. So the sun is shining on the left side of the first stick, and a stick I casts a shadow on every other stick j. So for example, if you have an array like this, and if you have stick I, and stick j is every other value greater than, so it can be from this index to the last index. If any other value is less, then it will cast a shadow. So this will cast a shadow. So if a shadow is cast on a cast on a stick, that would mean that the sunlight detector won't go off. So how many sunlight detectors will go off in total? So this is the problem statement, and I hope everyone got the problem statement. Aryan Raina says, keep taking the next largest stick and add one to a counter. Yeah, that's exactly the answer. Congrats. So if you guys have your own solutions, please let me know in the comments. Number of prefix maximums. I am not exactly sure what you mean by that. Nishay says the number of prefix maximums, but I don't exactly get what he's trying to say by that. If you could explain, Nishay. So Kanak Shiledar asks, will 13 cast a shadow on only 4 or 4, 6, 9? It will cast a shadow on 4, 6, 9. So you can assume that the sun is directly adjacent, directly adjacent to the first stick. So this will cast a shadow on every stick lower, even if it's after, after the next value. So this will definitely cast a shadow on every other value. Yes, Nishchay, you are right. So if you, he means that max of I is the largest height till index I. The answer is the number of distinct elements in the max array. This is exactly the answer. So Aryan Raina's answer was to keep taking the next logistic and add one to a counter. And this is also the same thing, but in a different way. So this is your answer is right. Congrats. So now let's take a look at the answer. Find the largest increasing subsequence starting with the first value as the first tick. So this is a bit complicating way to denote what Aryan Raina and Nishay said. So this is the how the official term you would call this. So we are going to be talking about what this means. Find the first occurrence of a stick I after the first tick. So say first tick is value 5. So let's take a look at this one. Sorry, not this one. Yeah, let's take a look at this. So take the first value and take the next value greater than that. So find the first occurrence of a stick I after the first stick such that its height is greater than the height of the first stick. So this is equal to, so after the first stick, which is 5, next value greater is 7. So 5 and then 7. So the next value will be, then find the first occurrence of stick j after stick I. So stick I is equal to 7 and find the first value, first stick or j after stick I such that its height is greater than the height of stick I. So basically the next greater value is 12 and repeat the process. Repeat until there are no sticks left. So basically you just have to take 5, 7, 12, 13, 15, 19 and 20. These are the answers. So for these types of problems, the best way is to visualize the answer. So let me show you exactly how you can do that. So let's say you have the sticks like this. So say you have some sticks like this and the sun is shining on the left side of the first stick. So the sun is here and this, we can eliminate every value that's lesser than this stick. So this stick will cast a shadow on every value smaller than the current stick. So anything that is smaller, for example, like this, will will be eliminated because the sunlight detectors will be removed from the top of this stick. So you just have to remove every value smaller than the current value. So and then take the next value. So this part is completely removed. So this part is completely removed and this is another value and this casts another shadow on these two values. So these two are removed, these two are completely removed and the final one remaining is these two and this casts a shadow on this stick like this. So basically you just have to visualize this array, visualize this array and take a look at which values will cast a shadow on which other stick. So basically if you notice that the maximum sticks will never be casted a shadow upon. So any value larger will only, the largest value will cast a shadow on smaller values, but the smaller values will never cast a shadow on the larger values. So basically, you just have to take the continuous largest sum. So for example, in this case, the largest sum is like this. But if say this was removed and this was smaller, then the largest increasing subsequence will be first to second and second to fifth, sixth. Okay, sorry. Okay, so now I guess everyone got it. If you didn't, please react with the confused emoji. Okay, so one person didn't get it. So if you could explain what you didn't get, or should I, explain the problem in a brief manner again? And sorry for the crackers, guys. It's at Diwali, so I can't stop anyone, unfortunately. Yeah, let's crack it on hashtag Unacademy. So that's actually Unacademy's motto. Let's crack it. So let's crack some firecrackers and enjoy Diwali. Okay, so let me move on to the next problem. First of all, let's talk about the implementation first. Okay, so current equal to array of 0. So we are going to be initializing it as array of 0, which is the first value. And then we are going to be taking the first value, and then we are going to be taking the next value, which is greater than the first value. So this will be first, is second value, which is greater than the first value. So for example, we are going to be initializing count as 0. Actually, sorry, this count should be 1. So because the first one will always be, going on. So for each height of the sticks, if height is greater than or equal to current, if the current height is greater than, the height of the current stick is greater than the previous stick, we can just, initialize current as height and count as count plus 1. So we are going to be increasing count by 1, because the first stick has been the sunlight detector has been gone off in the first stick, and then the second stick will have some other value, and the third stick will have some other value. And in these cases, if say there's something like this, in this cases count equal to count plus 1 for each value that changes the current max. If the current max is changed, that means that the size of the value, is greater than the previous one, so there isn't any, any shadows casted on the stick. So now, this is the implementation. If you could take a look, if you couldn't understand any of this, please let me know. Nikhil Jose asks, why can't we see others chat? It's weird to see only the answers in the chat. Yeah, it is actually, you have to buy Pro, I guess, for seeing other people's chat. Yeah, sorry for promoting firecrackers, but it was Unacademy's motto. Yeah, let's crack some problems and get AC. So I guess everyone got this implementation. Did everyone get the implementation? Please react with a confused emoji if you didn't. Oh, why did you initialize count equal to 1 instead of count equal to 0? Ronak asks that. And that's the reason is because the first stick will always have, the first stick, sunlight detector will always go off because the sun is shining on the right side of the first stick, left side of the first stick. So the first stick will always have the value. And for each side of the sticks, actually this should ignore the first stick, ignoring the first stick. So please remember that we are going to be ignoring the first stick. So the first stick has been removed. And then we are going to be taking the height is greater than or equal to current and all the other stuff. So it's initialized as 1 because array of 0. So array of 0 is the first stick, will always go off. So we know that it's 1 at the beginning. Okay, shall we move on, guys? Okay, let's move on. I guess he got it, so let's move on. So the problem 3. Your task is to sort an array in increasing order by swapping adjacent elements. Swapping two adjacent elements takes time equal to the minimum of the two adjacent elements. So what is the minimum time it will take to sort the following array? And you are provided with this array. When will the class end, bro? It's still 15 minutes. It will end at 7. It's 1 hour, so yeah, actually, I'm really sorry. I'll take a look at the question start. What is the value of k? The value of k is equal to, I think you are talking about the first problem. So k is equal to the size of the window, size of the k consecutive elements. So say the array is something like this. Then when k equal to 3, we will be taking these three elements and these three elements and these three elements. So the three elements come from k. So the three consecutive elements is equal to k. So the size of this consecutive element size is equal to k. So we can use sliding method, and if j minus I is positive, then count plus plus. Yeah, that's right actually. Did you use sliding window to solve this problem, or is this just brute? So this is just I guess you were again talking about the sliding window problem. So that was sliding window. Uh, um, okay, so let me move on to the next problem. Setting them, let's first go to this. And again, please see the problem. So your task is to sort an array in increasing order by swapping adjacent elements. Swapping two adjacent elements takes time equal to the minimum of the two adjacent elements. So basically, so if you sort 5 and if you swap 5 and 2, it will take 2 time. If you swap 7 and 9, it will take 7 time, and so on. What is the minimum time it will take to sort the following array? So you can keep adding smaller element of all inversions to a sum. Um, Actually, yeah, Aryan Raina is again right. So the answer is to setting the minimum unsorted values to its right index is the most optimal method. For example, inserting 2 at this index, inserting 2 to 5 will be better than inserting 5 to the end, because it will take 5 plus 5 plus 5 plus 5 plus 5 so on. But instead, setting 2 in its right place will just take 2. So instead setting 5 here will take 2 plus 5 plus 5 plus 4 plus dot dot dot. But setting 2 will only take 2, and you sort one value, one index instantly. So this is the most optimal method. So this is, for each value it will take 1 times 2. So for each swap, it's the swap times the value. Number of swaps times value. So this is the this is the value, and set 2 in its right index. It will take one swap, and then set 3 in its right index. So this will first of all, let me just clear this. Okay. So 3 in its right index will be one swap, two swaps, three swaps, four swaps, five swaps, and six swaps. So it will take six swaps to bring 3 to index 1. So this is index 0 and this is index 1. So this takes six swaps. So now set 4 in the right index. So that will be 3 swaps. So 1, 2, and 3. So now this will be 3 times 4. This is 6 times, this is 6 times 3 plus 1 times 2 plus 6 times 3 plus 3 times 4 plus 6 times 2. 6 times 2 because we are going to be the next smallest value which is not sorted. So note that 5 is already in the sorted index, so we don't have to add anything. Or basically add 0 times 5. So 0 times 5 is the same as 0. So we are just going to ignore 5. So 5 is already in its right place. So 6 will, bringing 6 to its right index will take 2 swaps. So this is 2 swaps times 6. Okay. So the total time will be 1 times 2 times 1 plus 3 times 6 plus I just reverse the order. So this is value times swap. This is value times swaps. So 3 times 6 plus 4 times 3 plus 6 times 2 equals 44. So this is the answer. Basically, I am taking the minimal value and moving it to its right index. So that is the solution. Okay, let me read your comments. I sorted the array. Suppose that some element is at a position I in the original array and j in the sorted array. I added j minus I times k to the answer for each element if I is greater than j. Yep, that's the right answer. Will we be able to complete all the problems today or not? No, we are going to be solving half of the problems tomorrow. So, I guess everyone got it. If you didn't, please react with a confused emoji. Okay, so let me move on to the next problem. So, actually, oh, oops, I made a mistake with the title. So there wasn't any implementation for this. This is just a problem. So please ignore the title. So you are going to be asked a problem. So this problem is asking, you will be asked range queries for q times. Is this bubble sort? No, this is not bubble sort. I guess it has a name. I guess it's selection sort. Or maybe it's, yeah, I guess it's selection sort. I'm not sure. You'll be asked range queries for q times. So query of L comma R should return sum of elements from L to R. For example, if you have an array with 1, 2, 3, 4 and 5 and L equal to 0, L equal to 1, so L equal to 1 and R equal to 3. In this case, you should return a sum of elements from L to R. So you must return 2 plus 3 plus 4. So yes, this is prefix sums. So we are going to be actually talking about prefix sums now. So hopefully I'm going to cover as much as I can. Since we only have 8 minutes left, I'm going to cover as much as I can and we'll continue tomorrow. No worries. And so now 2, 1, 2, 3, 4, 5 and L equal to 1 to L equal to R equal to 3. So we are going to be adding the sum. So now take a look at the brute force implementation. So the brute force implementation is for query equal to 1 to q. So for q times, basically this repeats the following code for q times because they are q queries. L comma R equal to user input. So L comma R can be your input such as 1 comma 3 or 0 comma 5, 0 comma 4 or anything like that. And sum is initially equal to 0 and for I equal to L to R, sum equal to sum plus array of I. So I'm just adding all the elements. That's it. I'm adding all the elements. So did you guys get the brute force implementation? It's really simple. So I just did what I said in code. That's it. So basically I'm doing this part in code. So this is how you write it if it was a code. Yeah, if you didn't get it, please react with a confused emoji. Please don't hesitate later. So we are going to be now talking about prefix sums and how it works. Prefix sums is the list of the sum of prefixes of an array. So this is what prefix sum officially means. This is the solution. I mean this is the sorry, definition. What was the term you were saying? The term of prefix sums, I guess. That's what you're asking, I guess. And prefix sums is the list of the sum of prefixes of an array. In other words, prefix sum is the sum of elements of in an array from 0 to I. So for example, if you have elements like 1, 2, 3 and 4, I'll just be taking 1 plus 2 plus 3. So first of all, it will be 1 and then 1 plus 2 and then 1 plus 2 plus 3 and so on. So this is what prefix sum means, but we are going to be computing this in an efficient manner. So notice that 1 and 1 plus 2, 1 plus 2 depends on 1. So 1 plus 2 is equal to 1 and I am adding 2 to it. So notice that let's call this the 0th element of an array and first element of an array. Yeah, Suvit, you are right. Prefix sum is equal to cumulative sum. So 0 and let's denote this as index 1. Now 1 plus 2 depends on 1. So it depends on the previous value. I'll explain this more again. So 1 plus 2 plus 3 equal to 1 plus 2 plus 3 and 1 plus 2 is equal to the previous prefix sum value. The previous prefix sum value is 1 plus 2. So 1 plus 2 is the last value of the prefix sum plus 3. So we can describe uh, prefix sums as the previous prefix sum. So initial value of the prefix sum will be equal to the zeroth value. So array of 0 will be equal to the first value of the prefix sum, because the prefix sum of 0 elements, I mean the prefix sum of one element is the first element. So the second value will be, so let's say prefix of 0 is equal to array of 0, and then prefix of 1 will be equal to prefix of 0 plus array of 1. So this is what prefix of 1 will be. So if we substitute this, this will be a of 0, and a of 0 plus a of 1 is the prefix sum again. So this is the second value, and p of 2 will be equal to p of 1 plus array of 2. So now again, if you substitute this, this will be a of 0 plus a of 1. This is actually 2. So this will be a of 0 plus a of 1 plus a of 2. So now you can see how the prefix sum is constructed. So instead of calculating each subarray like this, so say the array was something like this, instead of calculating 1 and then 1 plus 2 and then 1 plus 2 plus 3 and then so on, we are just going to be computing 1 and then 1 plus 2 and then the last value. So 1 plus 2 is equal to 3. We know the 1 plus 2 equal to 3. So we are going to be adding 3 to 3 and we get 6. So that is 1 plus 2 plus 3 basically. So I guess everyone got that. Did everyone get that? Yeah, if you didn't, please react with a confused emoji. Or if you did get it, please react with thumbs up so that I can know everyone got it. Okay, could you go to the previous page? Sure. So actually there are also variations of prefix sums. You can take prefix max, prefix XOR, and so on. So they actually also prefix minimum, prefix maximum, prefix XOR, prefix OR. I don't think this prefix OR, I'm not sure though. So this is what prefix sum means. So we are going to be quickly going over the implementation, and we are going to be taking it tomorrow. Sir, can we use bubble sort and then calculate the time taken by the loop according to n for question 3? So we can actually, bubble sort will only take the consecutive elements. So I guess we'll be taking a look at the implementation tomorrow. I'll just answer the questions today. So consecutive elements doesn't mean the minimum. So we are going to be taking the minimum, for example, like 2 and, okay, let me, so we are going to be taking 2 and then we are going to be pushing it to the beginning, and then we are going to be taking 3 and pushing it to the next value to the beginning, and so on. But bubble sort doesn't do that. For example, if it's something like 5, 9, 2 and 3, we are going, it will swap, I mean 9, 5 actually. Let's make it 15. So 15, 9. This will swap 15 and 9. This shouldn't be swapping 15 and 9 because it's a bit how to say, not optimal. So it should actually swap 2 and 9 and 2 and 15, and then it will become 2, 15, 9 and 3. So then we will be swapping these 3, which will be 2, 3, 15 and 9, and then we will swap these 2, which is 2, 3, 9 and 15. So this is the optimal answer. Bubble sort won't work. I don't think bubble sort will work. And let's take the last answer. What is prefix max and prefix XOR? So actually we'll take a look at it tomorrow. There's only 20 seconds left in the in the solution, I mean in the session. So if you have any questions, please feel free to ask, and you can contact me on Discord via Sriv #5123. This is my username. And if you want to provide feedback, please do so at https. Yeah, you can DM me. Sure. Okay then guys, I'll be talking about this, we'll be continuing this session on 15th. Thanks. Thanks to meet you. Uh, thanks, Pranav. Bye, guys. Take care.